Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss chapter 1.3 that for the logarithms, log base A for n. Logarithm is a positive number, okay? So means that this number n must be positive to a given base. So this is n. The one to a given base is a, and then is the power which the base should be raised to get the given number. So this is the power. Okay, so means that you have a number, and then normally we write as an indices is a power of x equals to n. So when we change it to the logarithm, the base are the same, still base a, uh, to this number n, and then the answer you get it is the power. Okay, and over here please note that is the base cannot be 1, just like your indices cannot be 1, and your n, the value here must be greater than 0. Actually just same like our indices, that is anything, okay, let's say 2 power of 3 or negative 1 over 3 is impossible you get a negative number over here. So same thing over here, when we change it to logarithm, you cannot have a logarithm for any negative number. Okay, after that, we have two common logarithm. Okay, the first one is base 10. Some books they use LOGA, which they drop the 10 over here. So it is understood when people use log only means it's log base 10, or certain books they use LG only to differentiate that this is not the common arbitrary log. Okay, and then the second one is the one base e, the exponent. Actually this one is called natural log, LNA. Commonly use it in the engineering or the physics courses. Okay, so these two base on you can be found these two buttons at the common scientific calculator. Okay, but in the latest scientific calculator, you can calculate any other's base easily by using the latest scientific calculator. Okay, so now let us look at some of our rules of our logarithm. The first one is if you want to combine log x plus log y, the base must be the same. You can, when you combine this thing, you can become an multiplied, okay, xy. If this is a minus, it's become divide. And remember, all the base must be the same, okay. And then the third one actually is the most attractive properties of our logarithm. That is, if you have any power that you can bring it forward to become a log a x. Okay, and then these 4, 5, 6 are the other properties. Actually, these are properties of our logarithm. If you have an a, base to a, actually you will get 1. So means that actually is you have any number, any base, power of 1 always get the same thing. And then because of, we know that log a equals to 1. So when you have log a power of x, so by using the properties of 3, we can bring our x to in front. So I have log x log a x, sorry, log a. So this one is become 1. So I have an x equals to x. Okay, and then the second properties over here is if you have base, any of the base, if the inside is 1, so it is 0. This one actually from our indices is very easy to see. A power of 0 is equals to 1. Any numbers power of 0 except 0 is equals to 1. And then the number 6 is kind a little bit look weird. Actually is a base of log ax is equals to x. This one is going to make it you become 1. So this one push in front. Then this one you bring in front actually is x. Okay. Then these three are the properties of our logarithm. So now we have the 7 over here is changing the base. Changing the base sometimes is very useful. That is, if the information given to you that is not the base at the questions. Okay, they will require you to change it, changing the base. So you can change to any base you like. Okay, so for example, originally if you have a base 2, okay, so this one, let's say is an x, this is a y. Okay, sorry, this is x. Okay, so and then you look at, you want to find log 2 base 2 for 3, and you want to change it into base 10, which your calculator only support base 10. So what you need to do, you just take whatever base you like, log base 10, copy back what is inside the base 2, so this is 3, and divided by log, and what is the base is 2. So that is the way how you want to change it the base. So you can easily find the value of log 10 3 and log 10 2 from your calculator. This is when you want to change the base. And then the number 8 are useful. Okay, the number 8 is useful when you want to solve for the logarithm equation. This one you will see it during the chapter 2 equations. And then what they say is you must have the similar base, and then we say what is inside must be the same as like in the indices. Please don't go and cancel these two, they are not cancelable. Okay, we are only comparing left and right are same because the base are the same, means that the inside here must be the same. And then there are few common mistakes that is always happen is when left hand side, if they provided you the right hand side, you know that log a x equals to plus log a y equals to log xy. But certain time when the question required you to solve log a x plus y, because of that moment you desperately want to solve the question, you created your own formula, that is by separating that this one is log ax plus log ay. Actually this one is wrong, we cannot solve this thing. Okay, you need to find others way to solve it, we don't have any formula to change this particular thing. Okay, and then the second common mistake is always happen, actually is from the right hand side. When I have a log ax divided by log ay, some of you are just thinking that log and log are the same, so you change it to become log ax over y, and you should know that is log ax over y actually is defined by log ax minus log ay. And then the last over here, that is, sometimes you are mistakenly, the number 3 are similar to the number 3 over here. If you look at it clearly, the power of r for these rules of logarithm are at my x. And then this power of y are for the whole inclusive of our logarithm. This one means that my log px is repeated for y times. Okay, compared to this one, actually is logarithm. My x is the one repeated pr time. So they are not the same. Okay. So now we look at first example in your logarithm is express the following in index notation. Okay, this one is from the definition of our logarithm. X a power of n, a power of n equals to n are interchangeable with x equals to log a n. So for this one, we just following back. A is our base. Okay, so normally what I look at this thing is, this is my base. Power to this one, 3 power of 4 equals to 81. And half power of 3 is 1 over 8. And then 4 power of negative 3 is 1 over 64. And the last one, n power of half equals to n. Okay, and then we have another example. Now I provided you the index form that asks you to change back to logarithm. So we take the logarithm base 8, okay, this is base 8, to the number of 64 is going to provide you the power. So this is your base half, okay, and then to the number of 32 equals to negative 1 over, negative 5. And then this one base 4 to the number 1 over 16 is negative 2. And this one, please change back to the index x 1 over 2. So base x, okay, so base x to the power, okay, to the number of y equals to 1 over 2. Okay, now we look at the third example over here. Express the following in terms of log x, log y, and log z. So means that they already gathered together. They ask you to expand out. Okay, and why? Because if you look at certain question, they provide you certain value, and then they require you to find the new value by given value. Okay, so now we look arbitrary xy first. So how we going to expand this back to the log? Okay, so we are using the three common rules of logarithm. Log xy equals log x plus log y. Divided is minus, and then the power can bring in front. So this one is multiple. So I separated to become using the plus. And then this power of 2, I bring it to in front. So I have 2 log x plus log y. And then for number 2, this is multiple, so it will change it to become plus. This is divide, is going to change it to become minus. Okay, so don't forget everyone deserve a log. And then now I change my square root to become power of half. This one root 3, I become 1 over 3. And this one nothing, so I copy back. And this half I bring to in front. 1, 2 over 3, I bring to in front, and 4, I bring it to it in front. Okay, and then for this question, the don't get panic. It seems like not commonly. We just do it one by one. Actually, square root of 4, okay, root of 4 actually is 1 over 4. So 1 over 4, 1 over 4, then this one is multiplied, this one is divide, so it's plus and minus. And then we multiply the power here. Okay, then we have bring it to in front, 3 over 4. This one cancel, 1. And then this one is 1 over 2. That's all. Okay, and then the last one even look more weird. No need to panic. Just x copy back. And then this square, we change it to power half. And then this square, we change it to power half. And remember, by our indexes, this one multiplied here. So I have an x power of 1, okay, log x power of 1 over 4. The denominator is z power of 1 over 2. Okay, so that means you can notice that is I left out 1 over 2 over here. Okay, okay, so 1 over 2. When I bring it out, it's become okay, this one 1 over 2 minus 1 over 2. And then why this one is minus here? Because when I separated my log, it's become minus. And then this one is 1 over 2 in front. Okay, then we look at the next example. Evaluate the following without using calculator. So this one is just to test you on the how to relate the logarithm with the indexes. 81 actually we can rewrite as a 3 power of 4, and then the 4 we can bring it to in front, so become log 3, and we know that from log a equals to 1, so this one is 1. 4 multiple 1 is 4. And then this one 1 over 8. So 1 over 8, we change it to become 1 over 2. And then as the same thing, we bring it to in front. Log half is 1. So I have a 3. So how about log 3, 1? Okay, so log 3, 1, if you remember, okay, so if you remember, then you can know that this is directly is 0. If you couldn't remember, that we change our 1 actually is 3 power of 0. We change to base 3 because our base here is 3. So I change to base 3. So my 0 bring in front. Log 3 actually is 1. So 0 multiply 1 is 0. And then this one, I have 4 and 64. Okay, so I change my base, my 64 change to base 4. Why base 4? Because I want to tally with my this 4. So I have 4 power of 3. And then from the rules of indexes, I can bring this one up is become power negative 3. And this negative 3, I bring it to in front. Log 4 is 1. So that's why I have a minus 3. Okay, and then if the number over here is smaller than your base, so I know that actually 4 is 16